All right, so today we're going to be talking about geometric sequences, and first we need to know what a geometric sequence is. So it's basically similar to an arithmetic sequence. However, the difference is that rather than adding a common difference, each term is actually found by multiplying by a common ratio. Okay? So if we look at an example of a geometric sequence, we have 2, 6, 18, 54. Okay, this is a geometric sequence. So here, the common ratio can be found by taking term 2 and dividing it by term 1. So we take 6, divide it by 2, and that would obviously give us a common ratio of 3. So in order to get from 2 to the second term of 6, we multiply by 3, multiply 6 by 3 to get 18, multiply 18 by 3 to get 54, and so on. So to find the common ratio in that geometric sequence, we're just going to divide by the previous term. So for the example that's given, 3, 2, 4 over 3, 8 over 9, 16 over 27. Okay, what we are going to do is you can take any term. So we can take 2, and we're going to divide that by the previous term of 3. So our common ratio is going to equal 2 over 3. Okay, if we took 16 over 27 and divided it by 8 over 9, we would end up with the same ratio as well. So I'll just quickly show that to you because it's a little bit difficult, or maybe a little bit more difficult. So 16 divided by 27, in order to find that difference, the common ratio, we would divide it by the previous term of 8 over 9. Okay, if you remember your rules for dividing fractions, we're going to multiply it by the reciprocal. So we would take 16 over 27, multiply it by the reciprocal of this, which is 9 over 8, and we would end up with the same value of 2 over 3 once we simplify. Okay? So what we want to do next is talk about this general formula again for a geometric sequence. We're going to see a lot of the same variables used again. So let's start off with the variables. We have T1 obviously is equal to the first term. N is the number of terms. R is the common ratio. So rather than having a common difference of D, we have a common ratio this time, which is R. And then Tn, this of course is the nth term. Okay, so this is the only new variable, and it's just replacing D. So our formula is going to be Tn equals T1 multiplied by R to the power of n minus 1. Okay, so this is the formula that we are going to be working with. So let's take a look at some examples here. First example, suppose there's 3 bacteria present before they split into 2 separate bacteria. What is the general form for this relationship? How many bacteria are present after 10 times? So let's start by trying to find our general form. So if we start with 3, we know that after that they're going to split into 2 groups and become 2 separate bacteria. So our pattern that would be formed, we would multiply by the common ratio of 2, and this would be what we would be looking at. So our first term equals 3. Our ratio would equal 2. And the number of terms that we're looking for in this case is 10. So let's substitute this in. So our general form would be given as 3 multiplied by 2 to the power of n minus 1. Okay, this is the general form. From there, we want to find out how many bacteria are present after 10 splits. So we want to find out, after 10 splits, what is it equal to? So we multiply, substitute 10 in for n. So we have 3 multiplied by 2 to the power of 9, which equals 3 multiplied by 512, which then simplifies or multiplies to 1,536. Okay, so the 10th term in this sequence would be 1,536. Example 2, suppose you're using a photocopier to reduce the size of a picture to 60% of its original size. How big would the picture be if its original length was 42 centimeters and you reduced 5 times? So what do we know here? We know T1, okay, and we also know our ratio. We know the difference, okay? So using this same formula, we're going to substitute in what we know. So we're looking for the 5th term. Our first term is 42. R is equal to 60%. So we have to make sure we write this as a percent. And to write it as a percent, we're going to use 0.6 to represent that percent. And then n is 5 times again. So we simplify here. And we end up with 42 multiplied by 0.1296. So after we reduce it 5 times, the picture would have a length of 5.44 centimeters. The last example, in a geometric sequence, if the second term is 28 and the 5th term is 1,792, we want to find the first term, common ratio, and then state the first 3 terms of the sequence. So for this one, we're going to need to do a little bit of fill in the blank to try and solve this. So let's go with what we're given. We know that the second term is 28, so we don't know what the first term is. But we know the second term is 28, and the 5th term is 1,792. So we can start by using multiple formulas. So we know that for T2, that is equal to 28. Okay? We can substitute 28 in for Tn. And then we're left with TR multiplied by R to the power of n minus 1. N in this case is 2 because we're working with the second term. So what that would really simplify to is 28 equals T1 multiplied by R. Okay? Let's do the same thing for the other value that we know, 1,792. So this time we know that that's equal to the 5th term. So we're going to multiply T1 by R to the power of 5 minus 1, and we'll simplify. So here we have 2 different equations with 2 different variables. So once again, we need to work with that substitution or elimination property. And what I'm going to do is I'm going to isolate T1 in this first equation. So I'm going to divide both sides by R. So I would get 28 over R equals T1. I'm now going to take this value here and substitute it in for T1 right here. So 1,792 will equal 28 over R multiplied by R to the power of 4. 1 R will cross out here with 1 R here, leaving us with 1,792 equals 28 multiplied by R cubed. Divide both sides by 28. So we're just going to move this up here. So we would have 64 equals R cubed. Now we need to solve for r, so we're going to take the cubed root of 64 and the cubed root of r cubed, leaving us with 4 equal to r. Okay, so now we're asked to find the first term, the common ratio, and state the first 3 terms. So our common ratio is equal to 4. Okay, if we want to find this first term here, what we're going to do is take 28 and divide it by the common ratio to find that first term. So our common ratio is 4. 28 divided by 4 gives us 28. Then we need to multiply this by 4 to give us the next term, which would be 112. Multiply it by 4 again to give us the next term, which is 448. Okay, and that would be how we solve a question like that. Okay, assignment is given. We'll work on it in class tomorrow. Hopefully that was clear as glass.